A pipe of length L open at both ends contains a stationary sound wave with one node, as shown in the diagram. The frequency of the stationary wave in this pipe is 4F. A second pipe is open at one end and closed at the other end. A stationary sound wave in this pipe contains one more node than the stationary wave as shown in the diagram. The frequency of the stationary wave in the second pipe is F. The speed of the sound is the same in both pipes. What is the length of the second pipe? So immediately we should think of wavelength is speed over frequency. I'm going to use capital F here just to distinguish them. So if the frequency has gone down by a factor of 4, the wavelength has gone up by a factor of 4. So lambda new equals 4 times lambda old. So if we draw this setup in the new pipe, then to have a frequency of F, then this would have to be length 4L. So because it's going to look almost exactly the same, but then have one extra node, we must have something that looks like this. So we have antinode to antinode, and then it goes to just node fixed here, and this is equilibrium. So if you notice from here to here, this must be a half of that 4L, so this must be 2L. So the answer is 6L. So I knew this would be 4L because the wavelength has multiplied by 4, and because it's got one extra node, so it looks the same as the first setup, but it's got one extra node, so this part will have to be 4 times bigger than the original one because it's the same setup but with 4 times the wavelength, so we need 4 times bigger pipe. But then it's got an extra node, so we need to remember that extra 2L part here. So here it would have been an extra half L, and then here it's an extra half of that 4L. So if we had the same setup here, we would have got a 3 over 2L for this length, and then this one has gone to 6L. It's a bit of a tricky question because you probably won't have seen stationary waves with an open end. But the key idea with these is that when you have fixed ends, or if you have a closed pipe, for example, then you do develop nodes at the ends, because then you could think of it as the particles or the wave here kind of reflects back, and then you retain a node at that point. But then with the open end, tend to develop an antinode. And so the fixed condition is that when you have open ends, you get antinodes. When you have closed ends, you get nodes there. But you'll have to wait until university to understand a bit more about why this is the case. Hopefully this answer made sense, but if you have any questions, please let me know in the comments.